Hi everybody, David Peacock here, and I'll be honest, I'm struggling. We're talking about quadrilaterals, and I can't think of anywhere that we would be able to see four-sided shapes as an example. I can't think of a single place or way that we could talk about quadrilaterals. I just wish they were in the real world somewhere. Oh well, this is geometry. So today we're going to be talking about parallelograms. So the question becomes, what is a parallelogram? A parallelogram is a quadrilateral with two pairs of parallel sides. And to write it, you actually have to use a symbol that looks like a parallelogram. So this is an example of a parallelogram. You can tell it is because opposite sides are parallel. AB is parallel to DC, and BC is parallel to AD. So we would name this parallelogram ABCD. Now there are some other names we could give it. We could give it BCDA, CDAB, DABC. We could also name it ADCB, DCBA. The fact is, the only thing that we have to be able to do is we have to be able to say that we did not skip a letter. So for instance, you couldn't name it ACBD, but you could do ABCD, ADCB, any of those. So let's talk about some of the properties of parallelograms. If a quadrilateral is a parallelogram, then its opposite sides are congruent. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So the angles that are not adjacent. If a quadrilateral is a parallelogram, then its consecutive or adjacent angles are supplementary. And if a quadrilateral is a parallelogram, then its diagonals will bisect each other, meaning cut each other in half. That does not mean the diagonals are equal. They are not most of the time. So let's try some examples of problems like this. This asks us to find JK and LM. So in this case, what we know is that JK over here and LM are opposite sides. That means that they are congruent, which means we could say 7x equals 3x plus 14. At that point, 7x equals 3x plus 14. We subtract 3x. That becomes 4x equals 14. This does not make me a happy camper. Okay, so let's see. 4x equals 14. So that's going to be the x is, I believe, 3.5. Yes, so x is going to equal 3.5 when we divide by 4. At that point, JK and LM are going to be the same, so we can either multiply 7 times x, so 7 times 3 is going to be 21, times 7 times 0.5 is 3.5, so 24.5, and let's double check my math. So 3 times 3 is 9, plus 1.5, that's 10.5. Plus 14, that also gets us 24.5. So that is the length of JK and LM. Notice that they are congruent. Now, you probably guessed it, we're going to talk about L and M. Now notice that in this case, these angles are consecutive angles. Now, you might remember from a little bit of time ago, angles being cut by a transversal. These angles right here would be what are called same side interior angles. And same side interior angles are supplementary. You can also tell that because this angle and this angle are not the same. This one looks like it's obtuse, this one looks like it's acute. Now remember, that does not mean that one of them is acute and one of them is obtuse. It might be that they both are 90, or that the one that looks obtuse is acute, or so on and so forth. But it gives you the idea that they aren't going to probably be congruent, or at least that's not how we should set up the equation. So instead of setting it up as one equals the other, we set it up as we add one to the other, and it equals 180. So 5z minus 6 plus 2z minus 3 equals 180. So our first thing is that we go 7z minus 9 equals 180. Okay, so at that point, add 9, 7z, ooh, that looks like a 2z. 7z equals 189. Okay, so let's see, that's 27 because 14, so 140 for 20, and then there was 49 left over, so 7. So z is equal to 27. All right, now that we know that, we just have to plug it in to find our two values. So I'm going to plug it in to 2z minus 3, because if I was only going to do one, I'd do that one, because 2 times 27 is easier for me than 5 times 27. So 2 times 27 is going to be 54 minus 3, or 51 degrees. Now that means that this angle down here should be 180 minus 51, or 129, but let's double check that. So 27, so that's 135, so 27 times 5, because it's 100 plus 35, and then minus 6, that does get us 129, which means, yep, we did it right. Hooray, everybody. We're so good at math. All right, so next, this is going to be dealing with the fact that these angles are bisected, or these sides are bisected. So EFGH is a parallelogram. Find each angle, or find each measure, sorry. So that means that this and this are congruent, and then these are congruent as well. So if I want to find JG, what I'm going to do is I'm going to say 3W equals X, sorry, not equals W plus 8. Subtract W, that's 2W equals 8. That means W equals 4. So that means 4 plus 8 is 12. So 12. Ooh. And then FH, well, we set it up the same way. 4z minus 9 equals 2z. So at that point, let's see. I'm going to subtract 2z. That's 2z minus 9. So 2z equals 9. Z equals 4.5. That means this is 9. That's going to be 9 as well. So 18. Because we wanted the whole length. So 9 plus 9 is 18. All right, so here's our last one. 3 vertices of A, B, C, D are A1. B, A is 1, negative 2. B is 2, negative 3, negative 2, 3. And D is 5, negative 1. Find the coordinates of vertex C. So this question seems harder than it is, because the thing is, I don't have graph paper on me. Literally, I am looking around the room I'm in right now. There is no graph paper. It's the problem with me suddenly going into a new room. So what I kind of have to do is I just have to sketch it out. So remember, A, B, C, and D. I know that B and D, C is going to be in between those. So I'm going to start by sketching this out. So find the relative position of C. So I have A, B, C. These are all just sketches. Who knows exactly where it is? But so 1, negative 2. This is over and up. This is over and up. That means C is going to be somewhere around here. For the record, this is not actually a perfectly accurate drawing of this, but it doesn't really matter, because all that matters is I need to know that C is going to be around there. Now, we want to find the change in X from A to B or from A to D. Either of these work because of what we're going to be doing. So, for instance, I could go, this is 4 to the right and up 1, not up 4, up 1. So this is going to also be 4 to the right and up 1, which means 4 to the right would be 2, 4. Up 1 would be 4. So that is the position there. But let's look at it if we went a different way. So from here, this is going to be minus 3 and up 5. So minus 3, up 5. So 5 minus 3 is 2. Negative 1 plus 5 is 4. Yep, either way I get to 4. So that is how I end up getting the point for C. All right, so now let's talk about some of the conditions for parallelograms. So in this case, we actually already know, we're saying that these are facts about this quadrilateral. Is it a parallelogram? The first condition is obviously that both pairs of opposite sides are parallel. That is the definition of a parallelogram. So of course, if that's true, it's a parallelogram. But any of those other rules that we had pretty much, well, almost will be. So if we have a pair of opposite sides that are parallel and they're also congruent, then this will also work. And the reason why is, if these are parallel and congruent, then this distance will have to end up being the same if this is the same length and they're going in the same direction. So if we know that, that's enough to prove it's a parallelogram. Prove, oh, I think I know where that's going. Gross. Proofs. All right, both pairs of opposite sides are congruent. All right, so 1, this is apparently the world's longest line, that first one, but yeah. So if both pairs of opposite sides are congruent, then it has to be a parallelogram. If both pairs of opposite angles are congruent, so one angle is supplementary to both of its consecutive angles, and the reason why is we already know that all the angles have to add up to be 360. So if we had 115, 55, and 55, the third angle will have to be 115. You can do the math now and check it out. I can wait. All right. Next, the diagonals bisect each other. If that is the case, then that is enough to prove it is a parallelogram. All right. And so now we have the question of, is it a parallelogram? All right, so here what we have is we have one set of lines that are parallel and one set that are congruent. But you might remember we needed one set that it was both. The fact is that, well, this one looks like a parallelogram, and to be honest, it is. I just took one and I labeled it. This could also be that picture, and that's definitely not a parallelogram. It's another shape that we'll find out about later, like in 2 days. Well, 2 classes. Okay, next. Is this a parallelogram? The diagonals are being bisected, which means it is. Yes, this is a parallelogram. Okay, so let's look at this one. Is it a parallelogram? Well, it doesn't look like one just yet, but what we have to remember is these two angles actually have to be the same because of the third angle theorem. If two angles in a triangle are congruent, the third angle is as well. And wait a second, this angle and this angle have to be the same. So opposite angles are congruent. That means, congratulations, it is a parallelogram. Next, is this a parallelogram? Well, opposite sides are not congruent. It's adjacent sides that are, which means, based solely off of the picture, we do not have enough evidence to prove it. Now it looks like all the sides are congruent, but we don't know that yet, so we can't say it. Okay, so this one says, use the definition of a parallelogram to show that a quadrilateral with vertices K, which is -3, 0, L, -5, 7, M, 3, 5, and N, 5, -2 is a parallelogram. So the first thing I'm going to do here is I'm just going to sketch. So -3, 0, that's K, -5 and up 7, so that's L. Okay, so 1, 2, 3, 4, 5, 6, and up 5. M is at 3, 5, and N is going to be at, so let's see. Five. Oh wait, sorry, that's a little bit lower. 5, -2. All right, so this is not the image I initially thought it was, but it does actually work. So, all right, what we need to do is we need to prove that this is a parallelogram. And we could do this a lot of ways. We could do distance formula, but I actually think the easiest way to prove if all we are given is points is just figuring out slope. So let's see, slope is, so this went -2, this went up 7, this went -2, this went up 7. So this slope and this slope are the same. So those two slopes are -7/2. And I'm going to also mark those as being parallel. And then let's see, from here, so this went down 2, and then, wait a second, that went 8, and then down 2, and then from -3 to 5 is also +8. So this becomes -2/8, or -1/4. Now, well, those are different numbers, and those are certainly not like perpendicular slopes. They do both share the same, so because of that, opposite sides are parallel. That means that the angles are, in fact, well, that means that the lines are parallel. So there we are. Opposite sides are parallel. That is enough to prove it is a parallelogram. Hooray! Also, if the 2 and 8 are the same, that's the change in x and y. If the -2 and the 7 are the same, that's the change in x and y. That means opposite sides are also going to end up being congruent if we did distance formula. But ultimately, that's not what really matters. What really matters is much more simple, and that is that you like and subscribe. And you know what? Maybe comment as well. Exciting. Yes, like and subscribe, please. There you go. For more fire content like this one. There we are. So like and subscribe, everybody. Thank you all very much. Have a wonderful day. I will talk to you again next time here on Geometry.